Okay, skill set 3. The first bit is all about errors in measurements. This is upper and lower bounds. So whatever your number is, whatever your value is, and whatever it's measured to, the first bit is whatever it's measured to, you half that. For your lower bound, you subtract it, and for your upper bound, you add it on. So for example, if we've got it's measured to the nearest 0.1, you half that 0.1 to get 0.05. For your lower bound, you're going to take your number and you're going to subtract that to get 124.55, and for your upper bound, you're going to add it on. So if something's rounded to the nearest 10, we half that to get 5. Your lower bound, we take it away. Your upper bound, we add it on. For example, last one, if it's 100, for your half that is 50, lower bound, take it away, upper bound, add it on. If they ask for areas, for example, so they've got quite easy ones in here. It does get trickier in higher tier where you've got different shaded areas and etc. where you have to use a different upper and lower bound, especially if you're dividing. But these ones are quite straightforward. So if you've got a rectangle with these two measurements, we need the maximum minimum possible area. If it's measured near a centimetre, that means we half that to get 0.5. For our lower bounds, we take it away, and for upper bounds, we add it on. So the minimum area is going to be your two lower bounds multiplied, and your maximum area is going to be your two upper bounds multiplied. You've then got a little bit of converting fractions to recurring decimals. So this one is a little bit easier than going the opposite way. We've got recurring decimals going back into fractions. So all we need to do, I think this is wrong here. So they've got 3 over 11, but I think that's meant to be 2 over 11. Because 2 over 11 is 0.81. So you would just do how many times does 11 go into 2, basically, just divide them. Pretty straightforward. And then we've got some Pythagoras theorem. Pythagoras theorem tells you that these two sides, the square of those two sides is the sum. The sum of those two square sides equals the square of the hypotenuse. So if we are trying to find your hypotenuse, you're going to do, in this example, 6 squared add 7 squared and then square root it. If you've got your hypotenuse, you do very similar, you just subtract. So I like to tell my class that if you've got your hypotenuse, if you've got the height, you subtract. If you need the height, then you add. So you square, add or subtract, and then square root. Alright, let's start. I think I've jumped too many there. I think it's task... Oh, I'm lost now. Task 8, I think we started on. Nope, 7. Look, I'm all over the place, I apologise. Right, so our first one, a pen is measured 21 centimetres to the nearest centimetre. So first step is we half that. So half of a centimetre is 0.5 centimetres. For our lower bound, we're going to subtract that. So we've got 21 take away a half is going to be 20.5 centimetres. And for our upper bound, we're going to add that on. So we've got 21.5 centimetres. Next one, a road measures 125 metres, correct to nearest 10 metres. We're going to half that to get 5 metres. Lower bound, we're going to subtract it, so 125 take away 5 to get 120 metres. On our upper bound, we're going to add it on to get 130 metres. A dog weighs 24 kilograms, so nearest kilogram. Half a kilogram is 0.5 kilograms. Lower bound, we're going to subtract that, so we've got 24 take away a half is 23.5 kilograms. And upper bound, we're going to add that on, so 24.5 kilograms. Rectangle measures 15 by 5 centimetres, the nearest centimetre. What is a minimum and maximum area? So our minimum, we're going to take our lower bounds. So, because it's rounded to the nearest centimetre, that's going to be a half. Lower bounds, we're going to subtract them. So it's going to be 14.5 times 4.5. So 14.5 times 4.5 is 65.25 centimetres squared, because I've forgotten to write centimetres on those. And our maximum is going to be your upper bound, so we're going to take that half and we're going to add it onto both of those. So we've got 15.5 centimetres and 5.5 centimetres. Why did I randomly write centimetres on just that one? I don't know. We've got 85.25 centimetres squared. Right, next one we're converting to a fraction. I think that's meant to say decimal. So we're going to go, how many times does 6 go into 5? Now 5 can carry on as an invisible decimal with lots and lots of zeros. It is going to be a recurring one. So how many times does 6 go into 5? It doesn't. We're going to carry all that 5. How many times does 6 go into 50? It goes in 8 times, because 6 8s are 48 with a remainder of 2. How many times does 6 go into 20? It would go in 3 times with a remainder of 2, with 3 times with a remainder of 2. You can see a recurring here. So our answer would be 0.83, and that 3 is recurring. So we just need that recurring above 3. Next one, some people might know the nines, so the ninths, sorry. 4 ninths into a decimal, I should say. So we've got how many 9s goes into 4. So our 4 goes on and on and on and on. So how many times does 9 go to 4? It doesn't carry all that 4. How many times does 9 go into 40? Well, it would go in 4 times. Can't write 4 times, because 4 9s are 36 with a remainder of 4. How many times does 9 go to 40? 4 times with a remainder of 4. 4 times with a remainder of 4, etc., etc., etc. So our answer is 0.4. Right, a bit of Pythagoras. So we know that 5 and 3 are our A's and B's. We need to find our hypotenuse. We need our hypotenuse, therefore you know you need to add them. So we're going to do 5 squared, add 3 squared. That gives us 34. So to find our hypotenuse, we're just going to do the square root of 34 to get 5.8 centimeters. It is a length, so no need for squaring. Okay, so we square our numbers, we add them in this case, and then we square root. Next one, we've got our hypotenuse. So if you've got it, then you need to subtract. So it's always going to be your hypotenuse subtract your other side. So because otherwise you're going to have a negative, and we can't have negative lengths. So we've got 13 squared, subtract 9 squared, which is 88. Then we need to do the square root of 88 to get 9.4 centimeters. So we square them, in this case we subtract, and then square root. Find the length of the diagonal in a rectangle. I'm just going to quickly sketch this awesome drawing. So we've got 12 centimeters by 7 centimeters. We need to find the length of the diagonal. Oh look, we've got some Pythagoras, because it's a right angle there, because obviously it's a rectangle. We've got 2 sides. We need our hypotenuse. So if you need your hypotenuse, you can add. So we do 12 squared, add 7 squared, which is 193. We're going to do the square root of 193, which is 13.9 centimeters. Make sure it makes sense. Your hypotenuse does need to be your longest side. Right, now we can do task 8. So we've got an ant, okay, measures 21 millimeters to the nearest millimeter. So we need to half that. So half a millimeter is half a millimeter. So we've got 0.5 millimeters. Lower bound, we're going to subtract it. So we've got 20.5 millimeters for our lower bound. Upper bound, we're going to add it. So we've got 21.5 millimeters. Bottle containing 300 milliliters, correct nearest 10 milliliters. We're going to half that, so that's 5 milliliters. Lower bound, we're going to subtract 295 milliliters. And upper bound, we're going to add it, so 305 milliliters. A dog weighs 31.4 kilograms to nearest 100 grams. So we're going to half that, so that's 50 grams. Or we want to put that into kilograms, so that's going to be 0.05 kilograms. Lower bound, we're going to subtract, so that's going to be 31.35 kilograms. Upper bound, we're going to add on, so 31.45 kilograms. Okay, 16 squared paving slabs with a side of 60 centimeters, the nearest 1 centimeter, are used to make a square patio. What is the maximum and minimum area of patio? So very similar, just find the area, maximum minimum area, and then times by 16, because you've got 16 of them. So we've got nearest centimeter, so half of that is going to be a half centimeter. So for our minimum, we've got, oh, it's a square, isn't it? So the sides are going to be both 60. So we've got, for the minimum, we're going to do 6, because we haven't taken it away yet. So 60 take away a half is going to be 59.5. So we need to do 59.5, we're going to square that, and then we're going to times that by 16, because we've got 16 of them. So we're squaring it because we're just doing it times by itself. That's how we get our area of a square. And we want 16 of them, and hopefully my calculations are correct, at 56,644 centimeters squared. And then to get our maximum, we want the upper bound, so 60 to nearest centimeter upper bound is going to be 60.5 centimeters, and we're going to square that and then times by 16, so we've got 16 of them. So we've got 58,564 centimeters squared. Right, next one, we're going to convert 5/11ths into a fraction. So we're going to do how many times does 11 go into 5, and this goes recurring. So how many times does 11 go into 5? It doesn't carry it. So how many times does 11 go into 50? Well, it would go in 4 times, because 44, the remainder of 6. How many times does 11 go into 60? It would go in 5 times, because 55 with a remainder of 5. And then how many times does 11 go into 50? It would go 4, because 44 with a remainder of 6. How many times does 11 go into 60? Again, we can see a pattern here. It's going to go 5, 4, 5, 4, 5, 4. So it's going to be 0.54. Both of them are recurring, so you need dots above both of them. Why can't I scroll? Okay, we got 5 twelfths. So in this one, we want how many 12s goes into 5. So we've got 12 into 5, and this goes on and on and on, invisible, on and on. How many times does 12 go into 5? It doesn't. We carry all that 5. How many times does 12 go into 50? So that would be 4. 4 12s are 48 with a remainder of 2. How many times does 12 go into 20? It would only go in once, because 1 times 12 is 12. That would be a remainder of 8. How many times does 12 go into 8? That would be 6, because 6 12s is 72. So 72 with a remainder of 8. How many times does 12 go into 8? 6 with a remainder of 8, etc, etc, etc. So it's going to be 0.416 recurring. Just that 6 is recurring. Right, Pythagoras, we're going to square our sides, then we either add or subtract, and then we square root. So you add in if you need your hypotenuse, you're going to subtract if you've got it. In this one, I've got it, so I'm going to subtract. So we're going to do 8 squared, subtract 3 squared, and put my 8 first, otherwise I'm going to get negatives, and we can't have that. So that would be 55. Then we're going to square root 55, and that would be 7.4 centimetres. Next, Pythagoras, again, we're going to square our numbers, either add or subtract, and then square root. In this case, we need our hypotenuse, so we're going to add. So we're going to do 11 squared, add 5 squared, which is 146. And then we're going to do the square root of 146, which is 12.1 centimetres. Find the length of a diagonal of a square with sides 12. So if I got a very, very good square here, side lengths of 12 and 12, diagonal, we've got Pythagoras. We need that hypotenuse because it's our longest side opposite our right angle. So we're going to do 12 squared, add 12 squared. So that's going to be 144, add 144, which is 288. So we're going to square root 288, which is going to be 16.97 centimetres. Went to 2 decimal places there.